right, today we are going to be working with parallel and perpendicular lines, as well as discussing different types of angles. So we're going to be talking about right angles, acute angles, and obtuse angles as well. So let's begin by discussing what the words parallel and perpendicular mean. So first, let's look at the word parallel. So parallel lines will never intersect. That just means they will never cross. They can continue forever and they will never cross. So if I were to take these two sheets of paper, I have this little note card and then I have this pink note card, and if I were to angle them as such, let's move that. Okay, if you can look at the lines, so this line and then this line, you can see that up in this area they would intersect. So they would not be parallel. So to make them be parallel, they would have to be perfectly spaced. You see that? Okay, they would have to be perfectly spaced, and now they are parallel. So this line could extend forever, and it would never intersect this line. Okay, so that is what we call parallel. Now, the symbol for parallel is kind of fun because if you look at the actual word parallel, do you see this double L? That is the symbol for parallel. So it looks like an 11, but the lines are pretty close together. It's like a skinny 11. Okay, now let's discuss perpendicular. Perpendicular sounds super scary and fancy, but all it means is that the lines cross each other, they intersect, and they form 90-degree angles where they cross. So where they crisscross, it's going to make perfect corners. So let's go back to our papers here. So if I had my lines and I went like this, you can see that where these two lines cross, it forms this perfect corner. Do you see that? Like the perfect corner of an edge or something. So that would be perpendicular. Now, if I were to do this, you can see they're intersecting, but it did not form a 90-degree angle, so that would not be perpendicular. That would just be intersecting. In other words, they're crossing each other, but it does not form 90-degree angles, which are perfect corners. Okay, so perpendicular form the perfect corners. And the symbol for perpendicular looks like an upside down capital T. So you have your line going like that, and then you have a line on the bottom going like that. So it's an upside down capital T. Okay, so now what we're going to do is we're going to look at some shapes, and we're going to find the perpendicular and the parallel lines in the shapes. So let's look at, this is a rectangle. So there are things we know about rectangles. We know we have 90-degree angles. We know that we have, this side is the same length as this side, and this side is the same length as this side. So let's try to identify some parallel lines. So if I look here, I see that this line AC will never intersect line BD. So that would mean that they are parallel. So how you would write that is you would say line, I guess it's line segment in this case. Line segment AC is parallel to line segment BC or BD. Okay, so that tells us AC is parallel to BD. Now let's see if we have any other sets of parallel lines. Do you see any other lines in here that would never intersect? I hope you noticed that AB is parallel to CD. Do you see that? So we also have line AB is parallel to line CD. Okay, now that's all of them. Now let's see if we have any perpendicular. So You kind of have to imagine that these extend a little bit, right? Okay, you can think of them that way. Now let's look for perfect corners. I see lots of perfect corners here because this is a rectangle. So one of the characteristics of rectangles is that they have 4 90-degree angles, 4 right angles. So let's go ahead and we're going to say line AC is perpendicular to line CD. Do you see that? So right here where these two lines cross, it makes a 90-degree angle. So that is one set. So let's do line segment AC is perpendicular to line segment CD. Okay, there's our first one. And then let's see what else. AC is also perpendicular to AB. Do you see that? Because we have another perfect corner right there. So let's do that one. Line segment AC is perpendicular to line segment AB. Okay, we have more, right? We have line segment. Do you see there's another perfect corner right here? So we have line segment AB is perpendicular to line segment BD. And then guess what? We have one more. Line segment BD is also perpendicular to this one right here. So line segment CD. Now you could write DC, it doesn't matter, whichever order is fine. Okay, so look at all those. We have a lot. Okay, let's look at our next shape. We have a parallelogram. Now a parallelogram is kind of like a rectangle, but it's been smushed, right? So notice we do not have perfect corners here, okay? But we do have parallel lines, hence the name a parallelogram, right? So we're gonna have some parallel sides here. Notice that GH, line segment GH, is parallel to its match up top here, line segment EF. And then there's another set. Do you see? Line segment GE is parallel to line segment HF or FH, whichever. Now that's all, okay? We don't have any perpendicular lines here because we don't have any 90-degree angles. So if you don't have any 90-degree angles or perfect corners, you do not have any perpendicular lines at all. There are none, okay? Now let's look at the trapezoid. Right away, you should be able to tell there are no 90-degree angles in here. So there are no perpendicular lines. Do you see that? We don't have any perfect corners in here. Now let's check and see if we have any lines that are parallel. So I'm kind of imagining like this line right here, if I were to extend it up like that, right? And then this one over here, if I were to extend it up, they would cross. They would intersect. So that means they are not parallel, okay? Now let's check these ones here. So this one and this one, if you extend them, you can see that they are parallel. They would never cross. So let's jot that one down. We have line segment IJ is parallel to line segment KL. Okay, and that's it. All right, let's do another one. Here's a triangle. Now this was just a plain Jane triangle. It doesn't give us any type or anything. We're gonna check, let's look, do we have any 90-degree angles in there? Any perfect corners? No. So we do not have any perpendicular lines. Now let's check for parallel lines. I'm looking here, so this guy obviously intersects him. You see, there's an intersection point right here at the vertex. This intersects him, and this intersects him. So guess what? There are none on this one. This does not have any parallel, and it does not have any perpendicular. Okay? They don't have to have those. It's kind of a special thing if you have those, okay? Not every shape has them. All right, let's look at our last example here. We have, I messed up on triangle here, but we have a right triangle. notice it tells us something very important. It tells us we have a right triangle, and that means there is a right angle in here somewhere. Let's try to find it. Can you find a perfect corner in that triangle? If you said right here, you were correct. Do you see that that's a perfect corner? So that means automatically we're going to have some perpendicular lines here. Okay? So this would mean that line PQ is perpendicular to line QR. Do you see? Because that's the ones that form this perfect intersection, making a right angle. So PR over here, this diagonal line, does not have anything to do with this right angle. Okay? So let's go ahead and do line segment PQ is perpendicular to line segment QR. All right, now let's check for parallel lines. So as you can see, they all intersect each other, so there is nothing parallel in here at all. Okay, so this would be the only answer for that one. Now the next thing we're going to do is we're going to talk about angles. And then we're going to come back to our shapes and find angles. So our first type of angle is the right angle. So this is our perfect corner. So like on our little card here, look at all those right angles. You see? It has 4 of them. So perfect right angles or perfect corners are 90 degrees. Okay? So this right here is an example of a right angle. And sometimes it'll just have a little box there in the corner, and that will tell you this is a right angle. Okay? And that means it is 90 degrees automatically. Okay? So our second type is called an acute angle. I like to say this is a cute little angle. He's just adorable. He's so cute. So you can see these are less than 90 degrees. Okay? So they're smaller than the perfect corner. So this guy right here, to make him a right angle, this line would have to be like over here somewhere, right? Going up like that. Do you see? So it's a little smaller than this perfect corner. You see? See that? Okay, it's a little smaller. Now look at this little bitty one over here. He is also less than 90 degrees. Okay? Now, the last type is called an obtuse angle. And I kind of like to think of a sumo wrestler on these. The big guys who wrestle over in Japan. You can also think of them as like an obese angle. Obese means overweight, okay? So they're big ones, okay? They're big ones. So they are more than 90 degrees, but they're not a straight line, okay? So take a look. You can see, so here's my perfect right angle on my pink card here. You can see this is bigger than that, okay? So that would be obtuse. It's not a straight line, so that means it's obtuse or an obese angle. He's a little chubby. This one right here, look at him. He looks like he's pretty close to a right angle. Do you see that? But look, if I go like this, you can see it's a little bit past. You see that's a little bit more that way. So it's a little bit more than 90. So if it's a little bit more than 90, even if it's 91 degrees, it is an obtuse angle, okay? Now, look at this big one. A straight line would be literally right here on the blue line on my sheet of paper, okay, like this. And you can see it's just a little bit smaller than a straight line, and it's way bigger than a 90. So that is also an obtuse angle, okay? So, and the angles are usually marked with like a little arc, okay? Now what we're gonna do is we're gonna go back to some of our shapes, and we're gonna find angles. So let's look, and we're gonna use, if it's a right angle, we'll do the corner and we'll also put a little R, okay? So this is a rectangle, so you can see we would have 4 right angles. So I think in your homework they want you to put a little r there or something, okay? And that's it. That's all the angles. Let's look at the next one. So let's look at this little guy here, angle G. Notice that that is an acute. You see it's a little smaller than a right? Look at this one, look at its opposite right here. You see it's a little bigger, okay? It's a little past the perfect corner, so that's an obtuse. Now, if you look up here, his opposite, okay, which is F, angle F, he's also an acute. And then this one's opposite is an obtuse, a little bit bigger. Okay, let's look at our trapezoid. So if we start down here in this corner at this little guy, that's an acute. It's a little bit smaller than a perfect corner. Over here on the other side here, that's also acute. Look at this big one. That's a big one, so that's obtuse. And then this guy right here is also an obtuse, a little bit bigger than 90. Okay, let's look at our triangles. We have, ooh, look at this guy. He's a little one, he's a little one, and he's a little one. All three of these are acute. Okay, they're all, and that's fine. They're all acute there. Look at this guy. So we have a 90 there, so let's go ahead and say R for right angle. Look at this little one. That is an acute. And then this one right here is also an acute. Okay? All right, guys, that's it for today's lesson. Have a great day.